Terminating multiple ground wires under the same screw in the ground bar is generally acceptable. The ground wire's primary function is to provide a low impedance path for fault currents to return to the electrical service panel. The connection needs to be tight and secure to ensure sufficient conductivity for the ground wires to effectively carry fault currents. It is not generally acceptable to terminate multiple neutral wires under the same screw in a neutral bar. The neutral wire carries the return current for the electrical circuit, so each circuit's neutral conductor needs a dedicated termination point. If multiple neutral wires are terminated under the same screw, it can create a loose connection, leading to overheating and potential fire hazards. There are, however, exceptions to this rule. Firstly, in some cases, it may be acceptable to use a short pigtail wire to connect multiple neutral wires to a single screw on the neutral bar. This practice, known as pigtailing, involves connecting two or more neutral wires to a short piece of wire, which is then connected to the neutral bar. However, this should only be done if the pigtail wire is securely connected to each neutral wire and the bar. Secondly, some panels have dedicated neutral conductors for specific circuits. In these cases, it is acceptable to terminate multiple neutral wires from the same circuit under one screw on the dedicated neutral conductor. If you have multiple ground wires or neutral wires to terminate, it is best to use a larger ground bar or neutral bar with enough screws to accommodate all of the wires. This will ensure proper and safe connections. When working with electrical systems, safety should always be the top priority. If you are not comfortable working with electricity, it's best to consult a qualified electrician. If you have to work with electrical circuits, remember to always turn off the power before working on any electrical components. Double check the voltage with the meter before touching any wires to make sure the circuit is de-energized. The National Electrical Code, or NEC, provides detailed guidelines on electrical wiring and grounding. Familiarizing yourself with these codes can help ensure safe and compliant installations. Here are some other things to keep in mind. Firstly, ensure the ground bar is properly bonded to the metal enclosure of the electrical panel. Bonding creates a low impedance path for fault currents, enhancing the effectiveness of the grounding system. Secondly, when terminating wires, use the correct size screwdriver and apply appropriate torque to ensure a secure connection. Over-tightening can damage the screw or wire, while under-tightening can lead to a loose connection. Thirdly, always inspect the wire insulation for any signs of damage or deterioration. Replace any damaged wires to prevent potential electrical hazards. Fourthly, use appropriate wire connectors, such as wire nuts or crimp connectors, to join multiple wires together. Ensure the connectors are properly sized for the number and gauge of wires being connected. Fifthly, label all circuits clearly to avoid confusion during maintenance or troubleshooting. Use a permanent marker or label maker to identify each circuit by its function. Sixthly, when working with aluminum conductors, use antioxidant compounds to prevent corrosion at the termination points. Aluminum oxide is a poor conductor of electricity, so preventing its formation is crucial for maintaining a reliable connection. Seventhly, consider using a torque screwdriver to ensure that all screws and connections are tightened to the manufacturer's specified torque. This can help prevent loose connections and improve the overall reliability of the electrical system. Eighthly, before energizing any electrical circuit, perform a thorough visual inspection to ensure that all connections are secure, wires are properly routed, and there are no exposed conductors. Ninthly, use a multimeter to verify the voltage and current levels in the electrical circuit before connecting any loads. This can help identify any potential problems, such as overvoltage or overcurrent conditions. Tenthly, consider using ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs can quickly detect ground faults and interrupt the power supply, preventing serious injury or death. 11thly, use arc fault circuit interrupters, RFCs, to protect against arc faults, which can cause fires. SIs can detect abnormal electrical arcs and interrupt the power supply, preventing fires from starting. 12thly, ensure that all electrical equipment is properly grounded and bonded to the grounding system. This includes metal enclosures, conduits, and other conductive components. 13thly, consider using surge protection devices to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. 14thly, perform regular maintenance on the electrical system to identify and correct any potential problems before they become serious hazards. This includes inspecting wiring, tightening connections, and testing safety devices. 15thly, keep the electrical panel clean and free of obstructions to ensure proper ventilation and prevent overheating. 16thly, use only approved electrical components and materials that meet safety standards. Avoid using counterfeit or substandard products, which can be dangerous and unreliable. 17thly, follow all applicable electrical codes and regulations to ensure compliance and safety. 18thly, if you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electrical work can be dangerous, so it's best to leave it to the professionals. 19thly, keep a copy of the electrical panel schedule readily available for future reference. This schedule identifies each circuit and its corresponding loads, making it easier to troubleshoot and maintain the electrical system. 20thly, if you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, investigate immediately and take corrective action. Electrical problems can be dangerous, so it's important to address them promptly. 21stly, consider using a whole house surge protector to protect all of the electrical circuits in your home from voltage surges. This can help prevent damage to electronic equipment and appliances. 22ndly, use energy-efficient lighting and appliances to reduce energy consumption and lower electricity bills. This can also help reduce the load on the electrical system, preventing overheating and other problems. 23rdly, disconnect electronic equipment and appliances during thunderstorms to protect them from lightning strikes. This can help prevent damage to sensitive electronic components. 24thly, avoid overloading electrical circuits, which can cause overheating and fires. Use a circuit analyzer to determine the load on each circuit and ensure that it does not exceed the rated capacity. 25thly, install smoke detectors and carbon monoxide detectors throughout your home to provide early warning of fire or carbon monoxide leaks. These detectors can save lives. 26thly, develop a fire escape plan and practice it regularly with your family. This can help ensure that everyone knows what to do in the event of a fire. 27thly, keep a fire extinguisher readily available and know how to use it. This can help put out small fires before they spread. 28thly, if you have any doubts about the safety of your electrical system, consult a qualified electrician for an inspection and recommendations. 29thly, familiarize yourself with the location of the main electrical disconnect switch and know how to turn off the power in an emergency. This can help prevent further damage or injury in the event of an electrical accident. 30thly, consider taking a first aid and CPR course to learn how to respond to electrical shock and other medical emergencies. These skills can be life-saving. In addition to the recommendations already mentioned, here are some more detailed explanations about ground and neutral bars. Firstly, the ground bar serves as the central connection point for all grounding conductors within an electrical panel or enclosure. These conductors include equipment grounding conductors from branch circuits, grounding electrode conductors from the grounding electrode system, and bonding jumpers connecting various metallic components. The primary purpose of the ground bar is to provide a low impedance path for fault currents to return to the source, typically the electrical service transformer. This path facilitates the rapid operation of overcurrent protected devices, such as circuit breakers or fuses, to clear the fault and minimize the risk of electrical shock or fire. Secondly, the neutral bar, also known as the neutral bus, is the termination point for the neutral conductors of branch circuits. In a properly wired electrical system, the neutral conductor carries the return current from the load back to the source. The neutral bar is connected to the neutral point of the electrical service transformer, which is typically grounded. This grounding ensures that the neutral conductor is at or near 0 volts potential with respect to ground, providing a stable reference point for the electrical system. Thirdly, the proper installation and maintenance of ground and neutral bars are essential for electrical safety and system performance. Incorrect wiring or loose connections can compromise the effectiveness of the grounding system and create hazardous conditions. The NEC, which has already been mentioned, provides detailed requirements for grounding and bonding, including the sizing and installation of grounding conductors, the connection of grounding electrodes, and the bonding of metallic components. Fourthly, when terminating grounding conductors on a ground bar, it is important to ensure that each conductor is securely connected and makes good electrical contact with the bar. Use appropriate connectors, such as compression connectors or set screw connectors, and tighten them to the manufacturer's specified torque. Avoid over-tightening, which can damage the connector or conductor, and under-tightening, which can result in a loose connection. Fifthly, when terminating neutral conductors on a neutral bar, it is crucial to maintain a clear separation between the neutral conductors of different branch circuits. Do not combine neutral conductors from multiple circuits under a single terminal unless specifically permitted by the NEC. Combining neutral conductors can create a parallel path for neutral current, which can lead to inaccurate readings on ground fault protection devices and increase the risk of nuisance tripping. Sixthly, in some cases, it may be necessary to install additional ground bars or neutral bars to accommodate the increasing number of circuits or grounding conductors. When adding additional bars, ensure that they are properly bonded to the existing grounding system and that all connections are made in accordance with the NEC. Seventhly, regular inspection and testing of ground and neutral bars are recommended to ensure that they are in good condition and functioning properly. Check for signs of corrosion, damage, or loose connections, and tighten or replace any defective components. Use a ground resistance tester to measure the impedance of the grounding system and verify that it meets the requirements of the NEC. Eighthly, in addition to the general requirements for ground and neutral bars, there are also specific rules for certain types of electrical systems, such as separately derived systems, or SDS. An SDS is an electrical system that is powered by a source other than the utility grid, such as a generator or transformer. For SDS, the NEC requires that a grounding electrode system be installed at the source of the SDS and that the neutral conductor be bonded to the grounding electrode system. Ninthly, when working with electrical systems, it is important to be aware of the potential hazards and to take appropriate precautions to protect yourself from electrical shock or injury. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Tenthly, if you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the job. Electrical work can be dangerous, and it is important to ensure that it is done safely and in accordance with applicable codes and regulations. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns about electrical wiring or grounding.